Okay, boys and girls, we're looking at solving linear equations with unknowns either on one side or on two. And I'm just going to bring up a few more slightly more difficult examples because I've seen a lot of students make errors on the following kinds of questions. Now, I've got the advice from our previous video on the right-hand side saying eliminate the smaller unknown or keep the unknown positive. Now we can see this question doesn't have unknowns on both sides, but actually this second line can come into play for this kind of question as well. And I'll show you that in a second. Now, what I have here is one example, but I've split it up into two sides to show you two different methods. And they're both methods we've seen before, but it's just about keeping things clear. Now, the example on the left, I'm going to follow our usual method, which is where we try to isolate the term with the unknown in, which is the minus x. Not just x, it's the minus x. Which means if I'm trying to isolate that term, I need to get rid of this 7. Now to get rid of the 7, I need to subtract 7 from both sides. And that will give me 10 minus 7 is 3. 7 minus 7 cancels out, that's 0, and it leaves me with minus x. So 3 is equal to minus x. Not just x, very common mistake is to write just x, not just x, there is a minus here, so it's minus x. But I don't want minus x, I want the value of x. Now, minus x is the same as minus 1 times x, or minus 1 divided by x. So to get rid of a negative here, I could either divide or times both sides by minus 1. 3 times minus 1 is minus 3. Minus x times minus 1 is x. And we can see I now have x equal to minus 3. Now let's check that's correct. I've got 10 on this side. 10 is equal to 7 minus x, which was negative 3. And we know that if you have a minus with a minus next to each other like this, we get 7 plus 3, which is equal to 10. So 10 is equal to 10. The equation has worked. And that's one way we can do it. That's just our normal method of isolating the term with the unknown in. Now, the example on the right-hand side, exactly the same, but I'm going to show you a slightly different method for this. And we only ever use this if we have negative unknowns. Now, I've got this advice, keep the unknown positive. If I want to eliminate a negative unknown, I need to eliminate it from the right-hand side. To eliminate from the right-hand side, minus x plus x eliminates that out. But if I add x to this side, I also have to add x to the left-hand side. Now, I haven't got any x's up here. So if I've got 0 x's plus 1x, I end up with just 1x. The 10 was still there, that comes down. That gives me plus 10, because the 10 is positive, is equal to 7. 7 comes down. And the minus x plus x, that simply cancels out. Now, we're just solving this like we do normal questions. Our x is now positive, and we want to make it the subject of the formula or to isolate it. So if I want to isolate the x, I'm going to subtract 10 here and subtract 10 here. X on its own, 10 minus 10 cancels out. 7 minus x is negative 3. And we can see we've got the same answer here as we did here. It does not matter which method you use. If you prefer to isolate the unknowns this way, that's fine. If you'd rather make the unknown positive first, that is also okay. Either method is fine. You can choose which one you want to use. Okay, now I've got one follow-up example. This is with unknowns on both sides And again, a bit more complicated because we have negatives on both sides and negative unknowns and negative numbers as well. So I've seen a lot of students struggle with questions like this or make little mistakes. So I'm going to show you the method quite clearly, and so we can see it modeled out for us in a better way. Now, we've said when you've got unknowns on both sides, we need to eliminate the smaller unknown, which will keep the unknown positive. Our unknown terms are the minus 4x and the minus 9x, not just 4 and not just 9, minus 4 and minus 9x. And we need to eliminate the smaller unknown. Now, if we think of temperature, minus 9 degrees is colder than minus 4, so minus 9x is the smaller unknown. We have to add 9x here to eliminate this, and add 9x here to keep it consistent. Now, if we've eliminated on both sides, or on one side, the 1 didn't do anything, comes down. Minus 4x plus 9x is plus 5x. Minus 4 plus 9 is 5. Minus 9x plus 9x is going to cancel out, and the minus 7 is going to come down, which means this is equal to minus 7. A common mistake is to forget about this minus. You can't. That minus is part of the 7. So 1 plus 5x equals to minus 7. We now follow our usual method of isolating the term with the unknown in, which is the 5x or the plus 5x. That means we need to get rid of this 1 from both sides, minus 1 and minus 1, gives us 5x is equal to negative 8. Minus 7 minus 1 is 8. 1 minus 1 cancelled out. And now the last step here is we'll notice that 5 doesn't times by a whole number to get negative 8. So our answer here is going to be a fraction or a decimal, which is completely fine. If I divide this side by 5, I have to divide this side by 5. 5x divided by 5 is just x. Minus 8 divided by 5, you can write actually as minus 8 over 5. That's completely fine. But if you want that as a value, that is equal to either minus 1 and 3/5 or minus 1.6. And that's completely fine. Either of those answers is allowed. We've got one as a mixed number and one as a decimal. But we can still check that this is correct. Still important to check what we are doing is correct. So if we substitute this, I'm going to put this over here, switch this around. We had 1 minus 4x is equal to minus 9x minus 7. To make sure that this works, it's balanced on both sides. X, I'm going to write as minus 1.6. 1 minus 4 lots of minus 1.6 is equal to minus 9 lots of minus 1.6 minus 7. Now 4 lots of minus 1.6 is 6.4. That gives us 1 minus 4 times this. It's going to be minus 6.4. 1 minus minus 6.4 is 7.4. And on the other side, minus 9 lots of minus 1.6 is 14.4, because a minus is 14.4. A minus times a minus can be positive, and then subtract the 7 afterwards. 14.4 minus 7 is also equal to 7.4. So we've just checked it works on both sides. It balances, is equal, so it has worked. But the method was still the same. We eliminate the smaller unknown, which was the minus 9x, which made this a positive 5x. The unknown is now positive. And now we solved it accordingly. Subtract 1 from both sides to isolate the term with the unknown, and then divide by the coefficient, divide by the 5 to make x equal to minus 8 over 5, or minus 1 and 3/5, or minus 1.6. If you get stuck, please comment below, or feel free to message me. Thank you very much. Hope it made sense.